Identifying clashes, in addition to being a crucial aspect in a BIM context, also turns out to be something extremely practical when I have to install the components I have designed. In this regard, within Allplan, there is a specific functionality called clash detection, which can be quickly and easily accessed whenever needed using the CD key combination. With the arrival of Allplan 2026, this functionality has been further refined and improved, allowing you to configure clash detection by defining exactly which elements are involved and by setting a range of thresholds in terms of depth, in order to determine whether a clash is of the hard or soft type. Now, let's take a look at a simple educational example. Here we are inside Allplan. Within Allplan, a series of components have been created. We have solids and architectural components such as a slab, a wall, a column, and so on. Let's try pressing the key combination CD, which stands for clash detection, and then Control A to run a check with the standard classification set. As you can see, there are no types of clashes. Now, intentionally, we are going to create some clashes. So I will lower this 3D solid downward by a certain value, as well as this one on the right, so that there is essentially a clash between the 3D objects and the slab. At this point, I press the CD key combination again, do a nice Control A, and enter the definition and customization of clash detection. I can now, right now, successfully create my very own clash detection by myself. So now I will check the 3D objects together with the architectural objects. After that, I will define what I want to check. For example, I want to run a check on both hard and soft clashes, defining the information related to the depths. Let's click OK. At this point, from the drop-down menu, we select the clash we have customized. I click OK, and now the program has identified two types of clashes for me, too soft and too hard, based precisely on the depth information we specified. Everything can be easily displayed within the information palette, which, among other things, thanks to the ability to define groupings, allows me to isolate and group the hard clashes and the soft clashes. Here, at a certain point, I can decide whether a clash has been resolved or not. So how do I resolve a clash? I could move my object upwards so that the clash no longer occurs. Okay, so we've moved it upwards, and at this point, by selecting the hard clash we had previously defined and choosing to update the clash, and by viewing everything within the information palette, we can see that the clash has been automatically resolved. Let's now try another type of example. Let's try to check the distance between these two 3D objects. Their distance is 100 millimeters, okay? What is the goal of this exercise? It's to check whether their distance is sufficient. So instead of thinking in terms of clashes, we'll be thinking in terms of gaps. Now let's go and create our new type of clash, the gap. Between what? Between, in this case, two 3D elements. I'm going to define a hard and a soft clash, and here I now have the option to directly enter a negative value. So I'm telling it, if it's less than 200 millimeters, then at that point, identify it as a clash. Why? Because, for example, imagine you need to insert a bolt between two elements, and at this point, being able to check whether the worker will be able to install it or not becomes essential. Everything, as is usually the case, can be analyzed directly and in detail within the information palette, which allows me to assign a whole series of information to those clashes.